Hey guys, in this video I'm going to go through the general rule for transformations, focusing on reading and describing transformations when written in function notation form. The function notation form is the quicker way to read, describe, and to write the rule of the transform function compared to using the mapping notation. So in this video, I'm going to cover the theory and then I'll go through some basic examples. Now in general, if we have y is equal to some function f of x, then applying the series of transformations, we can write the rule of the transform function in this form. So what does all these letters mean? The value of a, which is outside the function f of x, is going to dilate the graph or the function by a factor of a from the x-axis. Dilating from the x-axis means that we're going to keep the x-coordinates the same but multiply the y-coordinates by the value of a. And if there's a negative in front of the a, then this means that the graph is going to be reflected in the x-axis. The value of n, which is inside the function f of x, is going to dilate the graph by a factor of 1 on n from the y-axis. From the y-axis means that we keep the y-coordinates the same but multiply the x-coordinates by the value of 1 on n. Now this confuses many students, so make sure that you get this. The value of n will dilate the graph by a factor of 1 on n from the y-axis. And if there's a negative in front of this n, then this is going to cause the graph or the function to be reflected in the y-axis. The value of h, which is again inside the function, is going to translate or move the graph to the left or to the right. If the value of h is negative, then the graph is going to be translated to the right h units. And if the value of h is positive, then the graph is going to be translated to the left h units. Again, be careful with this value as well. It's always the opposite direction of the sign. And the value of k, which is outside the function, will translate or move the graph up or down. If the value of k is positive, then the graph is going to be translated up k units. And if the value of k is negative, then the graph is going to be translated down k units. And so these are all the combination of transformations that can take place. Now there is one thing that I want you to notice, which is very important when you're reading transformations in function notation, and that is that the x term inside the brackets has a coefficient of positive 1. And so whenever you need to describe the transformations being applied, you need to make sure that the x term inside the brackets is by itself and has a coefficient of positive 1. Otherwise, you could get the transformations wrong, especially if the function is also translated. I'll show you what I mean when I work through the examples. And so that's it for the theory part. Let's look at the examples now. State the sequence of transformations that has been applied to the first function in order to achieve the transform function. Part A. Y is equal to x squared. This is the original function. And looking at the rule of the transform function, we start reading it from the left. And so, reading from the left, we've got 1 on 3. This is outside the brackets, or outside the function. And so, this is going to dilate the original function by a factor of 1 on 3 from the x-axis. Then we've got the plus 3. This is inside with the x. And so, this is going to be the value of h. And so, we're going to have to translate the original function 3 units to the left. And then we've got minus 2 on 3, which is outside the brackets, which is not with the x. And so this is going to be the value of k. And so we're going to translate the original function 2 on 3 units down. And so these are going to be the 3 sequences of transformations that have been applied to the original function y is equal to x squared. And just as a side note, I'm writing the transformations in short form to keep this video simple. But in your exams, you would need to write the full description. Part B. The original function is y is equal to x cubed. Looking at the rule of the transform function, notice that the x term does not have a coefficient of a positive 1. And so before we start describing the sequence of transformations, we need to divide by a negative 1 so that the coefficient of the x term becomes a positive 1. And so doing this, we can rewrite the image function as y is equal to minus 2 times minus, and then x minus 1 all cubed plus 1. The minus here is going to reflect the original function in the x-axis. The 2 is going to dilate the original function by a factor of 2 from the x-axis. The minus here, which is inside the brackets, is going to reflect the function in the y-axis. The -1 is going to translate the graph or the function 1 unit to the right. And then the +1 is going to translate the graph 1 unit up. And so these are the 5 sequences of transformations that you would need to state. Part C. Y is equal to 1 on x, which is the original function. And looking at the transform function, again notice that the x term does not have a coefficient of a +1. And so we're going to need to rewrite this so that the coefficient becomes a +1. And so rewriting the image function, this is going to be y is equal to 3 on, and then we're going to divide by 2, which is going to be 2 times x plus 3, and then we're going to have a -1. And so reading the transformations, the 3 is outside the function. And so this means we're going to dilate the original function by a factor of 3 from the x-axis. The value of 2, this is inside the function. And so this is going to dilate the original function by a factor of 1 on 2 from the y-axis. The +3, this means we're going to translate the original function 3 units to the left. And then the -1 means that we're going to translate the function 1 unit down. And so for part C, we've got 4 sequences of transformations that we would need to state. Part D. The original function is y is equal to cos x. And looking at the transform function, reading from the left, we have the 2. This means that we dilated the original function by a factor of 2 from the x-axis. Then we've got another 2. This is the value of n. And so this means we dilated the original function by a factor of 1 on 2 from the y-axis. The -2 is inside the brackets with the x, and so this is going to translate the original function pi on 2 units to the right. And then finally the +3, which is outside the function, and so we're going to translate 3 units up. And so for part D, we had 4 sequences of transformations that we would need to state. And this brings us to the end of this video. If you found this video helpful, then let me know by clicking on the like button or commenting below. And if you want to practice and learn transformation questions, then log into the Maths Methods Club. And from the main topic, select Functions and Graphs. And then from the subtopic, select Transformations. And then group the questions by multiple choice. There's over 30 different questions that you can practice. Try them out and see how you go. Good luck, and I'll see you guys in the next video.